Okay, we're going to talk about isosceles and equilateral triangles specifically today. We've done a little bit of work already in our classification with these two types of triangles, so now let's extend that a little bit and look at their specific properties. So we'll start off with isosceles, and we've got a couple theorems here. And first of all, just a note, a theorem will be a statement that has already been proven. Right, so we've talked a little bit about theorems and postulates and those kind of things, but specifically a theorem has already been proven. Let's take a look at our first one, which is the isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite those sides are congruent as well. So if we look over here at our example, we've got our tick marks here to indicate that our segment RT congruent to RS. So then we can conclude that also angle T is congruent to angle S. So I could even mark arc marks here to indicate that the angle opposite each side also would be congruent. So again, if the two sides are congruent, then the angles opposite those two sides are also congruent. Looking now at our converse theorem, remember converse, we're just going to change the order of that if-then statement. So we're saying here that if two angles of a triangle are congruent, then the sides opposite now, those angles are congruent. So we're given here that angle N is congruent to angle M. So because of that, I can conclude that the opposite sides, so then segment LN and segment LM, would also be congruent. So let's look here at the example. You can use these theorems to find the angle measures in an isosceles triangle. We're trying to find the measure of angle E in triangle DEF. So if we look over here at what's given, we already know that these two segments or legs are congruent, and therefore we've got an isosceles triangle. So we should be able to conclude that our two angles opposite would also be congruent. So let's take a look. First, again, let's state that our measures of each angle, so the measure of angle D, must be equal to the measure of angle E. You'll notice that we've dropped our congruency statement here, talking about only measure, meaning that we're looking at a degree specifically. By this is the isosceles triangle theorem, as stated up above. From here, we took our measure of angle D, which is 5x degrees, and the measure of angle E, which is the 3x plus 14, and simply substituted from our diagram on the right. Simplifying here, we see that subtracting 3x from both sides, I'm left with 2x equals 14, and my final step would be dividing both sides by 2, and therefore I have x equals 7. So I can even test this information, and I can check 5 times 7 here would be 35 degrees, as well as 3 times 7, which will be 21 plus 14, I also have 35 degrees. So in answering the question, what's the measure of angle E, then that measure would be 35 degrees. On this first side, you're going to finish 1 through 4 and go ahead and complete that for your homework. The video will continue on the other side, so when you're ready, unpause it and continue. Next, we'll be looking at equilateral triangles. So we have a couple things here with a corollary. So quick note, a corollary follows a theorem, so it's already assumed to be true. So the theorem was true, the corollary then follows that theorem. So for a few here, we've got the equilateral triangle corollary. What that states is if a triangle is equilateral, then it is equiangular. So an equilateral triangle is then equiangular. So we're talking about congruent side lengths, then we can conclude congruent angle measures. Okay, the equiangular triangle corollary. Now we're just going from angles to sides. So if a triangle is equiangular, then it is equilateral. So now looking at angles first, if they are congruent and it's equiangular, then we could also conclude equilateral triangle as well. So let's look over at our diagram. If angle A is congruent to angle B is congruent to angle C, then, again, all my three angles congruent here, I can conclude that segment AB is congruent to BC, congruent to CA. So equal angular, equal lateral, and vice versa. So let's take a look at the example. We can use these theorems to find values in equilateral triangles. Let's find x in triangle STV. First of all, a couple things. Remember that all three angles in a triangle will sum to 180 degrees. And in this case, we're given an equilateral triangle as indicated by the side lengths, which means that the angles are also congruent, equal angular. So we've concluded then that it is equal angular. Again, by that corollary, if equilateral triangle, then equal angular triangle. And now let's think about what's happening with our degrees. If all three angles sum to 180 and all three angles are congruent, then each angle must be 60 degrees. So I can simply substitute 7x plus 4, and that should equal my 60. So 7x plus 4 equals 60 degrees here. Again, we know because the measure of each angle of an equal angular triangle is 60 degrees. Simplifying here, I'm going to subtract my 4 from each side, so 7x equals 56. And last step, we're just dividing both sides by 7. So x should equal 8. You can always go back and check your work. 7 times 8 is 56 plus 4, just to make sure we didn't make any careless errors. And now you will finish the rest on this page for homework, numbers 5 through 8, and bring both sides completed for class next time.